Back to the Cyber Pathshala, guys, and as we know that in previous lecture I have covered some basics of the block diagram reduction techniques, and now moving to the lecture numerical part. In previous video there is and this there that video was a little bit blur, so you can view the notes, and if you have a PC, so watch on the PC. It is clear. Okay, so moving to the first type of numerical, here the here we have a block diagram. Okay, so we have to reduce the block diagram and obtain a transfer function. Okay, as given in question. So we have to see that how we can reduce it. So as you can see that here two blocks are in cascade, but there is a takeoff point between them. So if you move takeoff point after a block diagram, after a block, so you can have a cascade connection between G2 and G3. So we just move takeoff point after the block G3. So as you move the takeoff point after the block G3, you have to multiply H1 G3 which H1, divide. Okay, divide. You have to divide because you are not getting here G3. Okay, so you have to divide with G3. And as you can see that if you move takeoff point after the block G3, you have a cascade connection, so you can reduce it with a single block G2 and G3. In cascade we have to multiply both the blocks, and in parallel you have just add. Okay, so you get this block diagram. Now as we can see that we have in the basics of the block diagram reduction technique, if you have more than three inputs and one output in a summer, you can just take two summers. So in the next step we just take two summers with that. Okay, with the negative feedbacks. And here we got that H2 with the negative feedback and G2 G3 is the gain. So you know the formula, G upon 1 plus GH when you have the negative feedback, and the sign changes when you have the positive feedback. Okay, so when you solve this, you can see that G2 by G3 upon 1 plus H2 G2 G3. Okay, so we reduce the block diagram into single block. Feedback again, we use that formula, G upon 1 plus GH. So you can solve in that manner and you will get this single block. Point to note here that in the next step you have the positive feedback here. So you have the formula is that G upon 1 minus GH. When you have the positive feedback, here the sign changes. Okay, so in this manner you can reduce these blocks and you'll get the transfer function C by R is equal to G4 plus G1 G2 1 plus G2 G3 H2 G2 H1 minus G1 G3 H1. Okay, this is the first type of problem. You will see in your exam, it's a very easy problem. And moving to the next type of the problem, just move to slide number 3. Here is the second type of question. In this block diagram you have to obtain a transfer function. Okay, so in this block diagram, here the r1 is given as 0. Okay, and input is given here R, and the output is C. Okay, so r1 is equal to 0, so this will be a takeoff point because here are only input and output, and here you can see the negative sign, so you have to multiply with the negative, and if you take it as a takeoff point, then you have two blocks in the cascade, so you have to reduce replace you can replace it with the single block diagram G1 H1 and with the negative sign, as we have the negative feedback. Okay, so from here you are clear about this block diagram. Then we have to reduce the block diagram. So what we can do is that we can move this summer before the block G2, and after that we can easily as you know that consecutively two summers can be interchanged. So after that we can interchange the two summers, so we just move the summer before the block G2. Okay, so as you move the summer before the block G2, okay, we have moved the summer before the block G2, and we got this block diagram. Okay, as you can see that we have two summers consecutively, we can interchange the two summers. Okay, we have just in the next step we have just interchanged the two summers. Moving to the next slide. Okay, here we can see that as we interchange the two summers, okay, here we got the with positive feedback H3, so we can reduce it as with the formula G upon 1 plus GH. So what we get is G2 upon 1 plus G2H3, as you can see that in this block diagram. Okay, here again we have this block diagram and this block. So what we can do is that we have to see that this block and this block is in parallel. So what we do is that we add two blocks that is in parallel and replace it with a single block. So we replacing this with the single block, and we get this block and this block in cascade. So in cascade connection we just multiply both of them, and we get a transfer function block diagram with a positive feedback. So we know the formula 1 plus GH. We just use the formula and reduce it with this transfer function. So guys, this is the second type of the problem. In the next lecture I will cover the next problems. Okay.